Okay, so we are now diving into lesson 1-3, video 4, and this is not vertical, but horizontal stretches and shrinks. Or you might also hear us call them compressions. So let's just dive right in. So now notice we are calling our value, instead of A in the last video, we're calling it C. Okay, so if C is multiplied to the variable of the function, then the graph of the function will undergo a horizontal stretch or compression. Let me just delete these two notes that I have here. Okay, so when a function becomes y equals f of c of x, so notice what's going on here. We have our variable x is being multiplied by a number on the inside of the parentheses. So anytime your variable is multiplied by a number on the inside of those parentheses, this is going to be a horizontal stretch or compression. So specifically, if your value is a number, and remember, like we said in the last video, all this means right here is that c is between 0 and 1, so maybe a fraction like 1/2 or 1/4. This is going to end up being a horizontal stretch. So notice that that's a little bit different. So whenever that value is on the outside, that would be a vertical compression. Okay, so it's different whenever that value, it's opposite day when that value is on the inside of the parentheses. When c is bigger than 1, when c is greater than 1, in the function y equals f of c times x, this is going to be a horizontal compression. So again, opposite of what we would think here. C is on the inside of the parentheses. So that's going to end up being a horizontal compression. Okay, so y is the opposite of vertical stretches and shrinks. Okay, so let's think about this, and there's going to be a visual on the next page. So the points on the graph, y equals f of x, are of this form. Okay, originally we have our input x, and then our output we call f of x. And sometimes you might hear us call this f of x just y. You have your input x and your output y. However, the points that have a horizontal shift are written of this form, where you have this constant on the inside of your graph being multiplied by x first before it's plugged into this function. So notice c is on the inside of these parentheses, and x is getting multiplied by c, this constant, before it gets plugged into the function. Okay, so we're going to look at, on the next page here, this example. So we're going to look at x being plugged in, and f of x, our output, is going to be multiplied by 3. Okay, so let's first look at this point right here on the graph. Okay, so just, you have this visual here. Originally we have our input x, and then we have 3 times x. So this point has the y value we want, but it has the wrong x value. The x value of the point is 3x, and we want an x value to be just the normal old x. So how do we get that? You have to divide by 3. So if it was a 3, in order to undo that, in order to unmultiply, you have to divide by that 3. Keeping the y value the same gives us this desired point of x comma f of x. So therefore the graph y equals f of 3 times x is the same, except that the x values have now been divided by 3, not multiplied by 3 like we would have expected. So that's why whenever c is bigger than 1, it ends up being a horizontal shrink instead of a horizontal stretch. And the same principles would be, the opposite would be true for whenever you have a value between 0 and 1. That's why it would be a horizontal stretch. What I like to say is that the graph is going, it gets a little confusing because the graph is going to look like that it gets taller when you have anytime, whether it's horizontal or vertical, whatever we're calling it, if you multiply by a number bigger than 1, whether it be on the inside of the parentheses or on the outside, it's going to look like that graph is getting taller. We just call it something different when you have that value inside the parentheses, and then vice versa for if it's a number between 0 and 1. Okay, and we call it something different because really there's something different going on behind the scenes. It just might be deceiving because it looks like it is. So let's look at these examples. Example 9a. Describe the transformation that would happen to the graph f of x is equal to x squared if it was multiplied by a factor of 0.5 such that g of x is equal to 0.5x raised to the second. And I'm actually going to rewrite this so that, remember this is the caret symbol on your calculator. So I'm going to rewrite this. It just puts whatever number is after it up into the exponent. So I'm going to rewrite this as, in parentheses, 0.5x raised to the second. Okay, so because the value on the inside of the parentheses, and you might also see it written like this, so 1 over 2x raised to the second. So because our c, so c is equal to 1/2 or 0.5, because that value is less than 1 but bigger than 0, and it's on the inside of the parentheses, this is going to be a horizontal stretch or compression. Okay, so the question is it a stretch or is it a compression? So when that number is between 0 and 1, that's going to take your values of x and it's actually going to stretch them out. Okay, so that's a horizontal stretch. And specifically, this is by a factor of the reciprocal of whatever c is. So because c is equal to 1/2, if I were to rewrite this as the reciprocal, it's going to be by a factor of 2. Because 1/2, if I were to flip it like this ends up being 2 over 1. Okay, a little confusing, but you've got to think the factor, the scale factor, is going to be the reciprocal of whatever that is. And that helps you remember that, that's going to be a horizontal stretch. All right, so one little correction in your notes, and ironically, my correction here is this word right here. It should say stretch. It's not going to make sense if it says shrink in your notes, so make sure that you cross that out and change that. But this should say stretch. So this one says write an equation that would horizontally stretch the parent function by 5. Let me get my pen here. Okay, so with this one, I'm going to go ahead and start by writing g of x because our new function is going to be a different function from f of x. And we're going to start with our base being 3. And in the parentheses, up top here, we're going to have x, and in front of x, and we're not going to put a 5 because this is a horizontal stretch. So remember, think opposite day on the inside of those parentheses. So if you're stretching by 5, that means the number that goes in front of the x is going to be, because 5 starts as 5 over 1, so when you flip it and get the reciprocal, it should be 1 over 5. Okay? Alright, so try the you try, and then we will see you in the next video.